Hello everyone, and in this video I'm going to introduce briefly what is ROC chart and a little bit about how it is constructed if time permitted. This part is optional, okay? So if just for interested students, if you want to look at how ROC chart in detail is generated, you can go to the Enterprise Miner documentation, look at the details 6.2, and also go to my, let me see whether I have that file. No, I don't have. Go to my note in week 8 inside the slides. Okay, in the slides I provided in week 8, there is the section about the algorithm of generating the ROC curve starting from slide 35. Okay, so ROC, another name for ROC curve is called the receiver operating characteristics. Okay, and what's the meaning of y-axis and what's the meaning of x-axis and what's the meaning of this 0, 0 point and 1, 1 point and this 0, 1. Okay, and also a calculation illustration of ROC curve, this one, okay, based on this model, okay, that generates the prediction, okay, probability of being 1 based on this model, and then ordered it, and this is the true class, how this ROC curve being generated according to the prediction and the true class, okay. So if you're interested, for interested students, this would be the details to show ROC curve, how it is generated. But we have explained ROC in the way that it is the rate of concordance, okay? So higher the better, and it's associated with the ROC index we have seen in the fit statistic from the model comparison note. The curve, okay, it's generated, and we find that the area under the curve is actually equivalent with the rate of concordance that the idea we have introduced. Okay, so graphically, it gives a better illustration of how is the model better or worse, okay, in ranking, okay, in considering about the rankings, okay. So so what is this ROC curve? If you look at the Enterprise Miner result, you will see that the y-axis is called sensitivity, and the x-axis is called 1 minus specificity. Okay, so the definition of sensitivity and specificity is depends on our decision matrix, and I have made a document to tell you what is sensitivity and what is specificity. So when we have a binary classification, okay, there are two classes for our responses, yes or no, or positive or negative, or 1 or 0, okay. And our model will give prediction or classification types of prediction. It could be predicted for every observation to positive case or yes case or the 1 case, or predicted into the 0 case or the no case or the negative case. So we have this confusion table. The rows means actual classes to choose, okay, and the columns are the predicted class based on the model, and this cell is the true positive cell, it's the correct decision, and this cell is another correct decision we call the true negative, okay, and these two cells are the mistakes, and we introduced in class last time. The one is type 1 error, one is type 2 error, okay. So what is sensitivity? Sensitivity is we call it the a true positive rate. Okay, so it is the proportion of the actual positive person who are correctly being identified as the positive correctness. So it's called the true positive. It is the proportion of this cell in this row. Okay, so it's the proportion of true positive among all the actual positive. No, proportion of true positive prediction among the all actual positive class. And specificity is proportion of this cell in this row. So it is the true negative rate, or the proportion of true negative prediction among all the observations are actually negative class. Okay. So both sensitivity and specificity are the kind of correct rate. Okay. The x-axis of my ROC curve is 1 minus specificity, so it is actually the proportion of this cell, the false positive prediction cell, in my second row, the actual class that actually no. Okay, so it can be considered as a kind of false positive rate. So the x-axis in my ROC curve is a type of mistake rate. The y-axis of my ROC curve is a type of accurate rate. So obviously we want that among all the positiveness, among all the actual positiveness, we want to capture it as many as possible. So we want sensitivity reach the top, okay, reach here. But for the error that says among all the negatives, I don't want to capture any of that. I don't want to predict any negatives being positives. I want my false positive being as low as possible. So I want to reach here to the left-hand side. So overall, that means I want that my model in this ROC chart to reach this 0, 1 point. Okay, so if my ROC curve from certain model is from here to here, okay, is this raise up and then go flat to the right, that is the best ever model. That means this model does not make any mistake. It ordered every positive observation correctly into the top and every negative correctly into the bottom. There is no negative being ranked before the positive observation. Okay, so that's my best model. So by comparing ROC curves, would comparing correctly whether my positive, the actual positives are correctly ranked before the negatives. Okay, so if we look at the ROC for my validation data set, it looks like there's no differences among a lot of tools, and little bit big differences from this curve to here. And if we check my ROC index, what's my validation? Yeah, validation ROC index. If I sort it from the highest to the lowest, you see there are a lot of ROC value that is close to each other, and then there is a big jump. That's big. It's not actually very significant because it's the third digit jump, okay, in my ROC index. And the best ROC is the tree that generated based on minimizing average square error. Okay, so this is my introduction about ROC curve. Again, if you are interested in the details about how this curve being generated, go to my slide from page 35 to 40, tells you the algorithm. And in the Enterprise Miner documentation. It explains also how this curve, what is the dot, okay, that makes the connection of this curve in this ROC chart, okay. And what is the x-axis? So x-axis is the 1 minus specificity. It is the fraction of secondary outcome captured, that mistakenly captured. Here is the mistake, okay. Capture means being predicted as 1. And y-axis is sensitivity, okay. We should have explanation of y-axis. Yes, y-axis is the primary outcome being correctly captured, So primary outcome is actually, the actual case is 1 being predicted into 1. Okay, so we stop here today for the videos. This week video are short because I think you need to spend more time in reviewing the tree models and go over my solution video for assignment 3 before you start assignment 4. Okay, next class we are going to start our new model, the logistic regression. So far in this diagram you can see we, where's my diagram? In the diagram we have explained a very basic modeling procedure. Start reading the data, transform, clean the data, and split in training, validation, testing, and try a bunch of models, and then finally compare and pick the best model. So this shows a short data mining process. And we are going to introduce additional tools over here. We're going to add a lot additional tools here, okay? Next class. So thank you for watching.